Hey there, science fans. Today, we're diving into the fascinating world of graph neural networks, or GNNs for short. Now, I know what you're thinking. Graphs? Networks? Sounds complicated, but trust me, it's not as scary as it sounds. Imagine a bustling city, full of houses, streets, and people going about their day. That's a lot like a GNN. In this city of data, each house represents a node. Think of it as a piece of information, like a social media user or a product on an online store. The streets connecting these houses, those are the edges, representing the relationships between those pieces of information. Friendships on social media, purchases in online stores, you name it. Now, imagine that the people in these houses love to chat with their neighbors, sharing news and gossip through megaphones. That's kind of like message passing, a key process in GNNs. Just like those conversations shape our understanding of our neighborhood, message passing helps GNNs understand the relationships within data. So buckle up as we explore this city of data and uncover the secrets of GNNs. We'll learn how they use nodes, edges, and message passing to make sense of complex information and even make predictions about the future. Ready for an adventure? Let's go! Let's start with the basics. Nodes and edges. Remember those houses in our data city? Each house or node holds valuable information. Think of a social network like the one on your phone. Each user is a node, and their profile is like the house, containing details like their age, location, and interests. Now picture the streets connecting those houses. Those are the edges, representing the relationships between users. Friendships are a classic example. If you're connected to someone online, that's an edge between your two nodes. The more friends you have, the more connected your house is to others. But edges can represent all sorts of relationships. Think about online shopping. If you buy a book, that creates an edge between your node and the book's node. The website can then use this information to recommend other books you might enjoy. See? Edges help us understand how things are connected. And the best part, these connections aren't random. They carry valuable information too. An edge representing a strong friendship might be thicker or shorter than one representing a distant acquaintance. These edge features give us even more clues about the relationships within our data city. Now, for the fun part. Message passing. Remember those megaphones? In our data city, nodes use them to chat with their neighbors, sharing information about themselves. This constant chatter is what makes GNNs so powerful. Imagine you're a node in this city, and you want to learn more about your neighborhood. You could ask your immediate neighbors, but what about the folks down the street? This is where message passing comes in. Each node shares information with its neighbors, who then share that information with their neighbors, and so on. This creates a ripple effect, allowing information to spread throughout the entire network. As messages travel, they carry valuable details about each node and its connections. The more messages a node receives, the more it learns about its place in the network. Think of it like a game of telephone, but instead of silly phrases, we're passing along important data points. With each exchange, the network gains a deeper understanding of the relationships between nodes and the overall structure of the data city. But what kind of information are these nodes shouting through their megaphones? Well, they're sharing their features. Remember those details stored in each node's house? Age, location, interests. Those are all features. During message passing, nodes share these features with their neighbors. For example, a node representing a music lover might share its favorite genres with its connections. This helps other nodes understand its tastes and potentially discover new artists they might enjoy. As messages travel and features are shared, the network begins to recognize patterns and similarities between nodes. Nodes with similar interests might cluster together, forming communities within the data city. This helps us understand how information flows and influences the network. And just like those megaphones amplify voices, message passing amplifies the importance of certain features. If a node receives the same information from multiple neighbors, it knows that feature is significant and should pay attention. Now, here's where things get really interesting. As nodes chat and share information, they start to learn from their neighbors. Think of it like this: you're more likely to enjoy a new restaurant if several friends recommend it, right? Similarly, in a GNN, nodes use the information they receive to update their own understanding of the world. If a node representing a movie buff is surrounded by nodes that love science fiction, it might start to give more weight to sci-fi recommendations. This process of updating based on neighbor information is called aggregation. Nodes take all the messages they receive and combine them in a way that makes sense for their own features. It's like taking all those restaurant recommendations and deciding which one sounds most appealing based on your own preferences. Through aggregation, nodes refine their understanding of their place in the network. They learn which features are important, which connections are strong, and how they fit into the bigger picture. It's like putting together a giant jigsaw puzzle, one piece of information at a time. So, we've got nodes, edges, message passing, and aggregation. But how do these pieces come together to make GNNs so powerful? The answer lies in the power of the network itself. Unlike traditional machine learning methods that treat data points as isolated entities, GNNs embrace the connections between them. They recognize that relationships matter and that understanding these relationships is key to unlocking valuable insights. By considering both the features of individual nodes and the structure of the entire network, GNNs can tackle complex problems that traditional approaches struggle with. They can identify patterns, make predictions, and generate recommendations with remarkable accuracy. It's like the difference between studying individual ingredients and experiencing a delicious meal. GNNs allow us to savor the full flavor of the data, capturing the nuances and complexities that make it so fascinating. Ready to see GNNs in action? These powerful tools are already making waves in various fields, tackling real-world problems with impressive results. Let's take a look at a few examples. Imagine you're navigating rush hour traffic. Wouldn't it be great if your navigation app could predict congestion and suggest alternate routes? GNNs can help. By analyzing traffic patterns and road networks, they can provide real-time updates and optimize traffic flow. Or perhaps you're scrolling through your favorite social media platform. Ever wonder how the algorithm knows which posts to show you? GNNs play a crucial role in understanding your interests and connecting you with relevant content. They analyze your connections, your activity, and even the content you engage with to create a personalized experience. And that's not all. GNNs are also used in drug discovery, fraud detection, natural language processing, and countless other applications. Their ability to handle complex relationships and uncover hidden patterns makes them invaluable tools for solving some of today's most challenging problems. As we generate more and more data, the importance of understanding connections will only continue to grow. GNNs, with their ability to navigate and learn from complex relationships, are uniquely positioned to thrive in this data-driven world. Imagine a future where GNNs help us develop personalized medicine, optimize energy consumption, and even predict natural disasters. By harnessing the power of connections, we can unlock new possibilities and create a smarter, more efficient future. The world is becoming increasingly interconnected, and GNNs provide the tools we need to navigate this complexity. By embracing the power of connections, we can unlock new knowledge, drive innovation, and shape a brighter future for everyone. So, there you have it, an inside look at the fascinating world of graph neural networks. We've explored the city of data, from the houses of nodes to the streets of edges, and witnessed the power of message passing and aggregation. But our journey doesn't end here. The field of GNNs is constantly evolving, with new discoveries and applications emerging all the time. I encourage you to keep exploring, keep asking questions, and keep marveling at the incredible power of connections in our data-driven world. Remember, science is a journey, not a destination. So put on your explorer's hat, grab your metaphorical megaphone, and join me in uncovering the endless possibilities of graph neural networks.
The first rule of channel is subscribe channel. Second rule of channel is click like. This channel will make you smart.